Hello, my name is James Halderson, and this is the fourth iteration of the dev log for the Thetis blockchain project I'm working on. Today we're just going to look at the encryption that I have added. I have implemented encryption into the blockchain for the few things that I was talking about. So the first thing that we'll look at today is the file encryption, and we'll just take a look at this little diagram here I made for it. So the basic concept is that the wallet object on your computer, on your device, it will be computer at first on Windows, and then I will try to go on to other platforms including Android, iOS. That will be in the future, but at first it'll be Windows desktop app. The encrypted wallet object is on your machine, and how this is created is that when you create a wallet on the Thetis blockchain, it'll encrypt the wallet and it'll be encrypted on your machine. Then when you want to do transactions on the Thetis blockchain node network, it'll decrypt it. Transactions and actions will occur and the information will change, and then whatever data is changed, it'll push it back to the encrypted wallet object. So let's look at that in action now. So we'll go over here and we'll see that in our little file here. I'll just get rid of this for now. We have this wallet here and we'll take a look at it. And we have the private key, public key, the address, the password. All this information will be stored at a local level. And then we have the token ID for this ETS token that's in here, which is called test, token value, all this stuff is in here. So let's go back over here and we'll say encrypt file. And this will ask us for the address of the wallet that we want to encrypt. So we'll go here and we'll grab that address. If I can just rename it. And we'll put that here. And then we can go up here and we can look and we can see that this is now the encrypted string of that file. So the file has been encrypted. This is the encrypted string. We go back to the file that we just looked at. We can see now that the information here matches this information. It has been encrypted. And this is how it will work, is that whenever a wallet is saved back to the computer, it will encrypt the file as an encrypted string. So let's try decrypting that file. Again, enter the wallet address that you would like to decrypt. We'll give the same one. And as you can see here now, the decrypted file is this information here. So we'll close this file and we'll reopen it because it doesn't automatically update. And we can see that it has now been decrypted again. The information is back and it's in a usable state, like this, where it will be used on the blockchain from JSON format back to a decrypted string here that we can utilize and transact and do actions on it here. So it's all fine and dandy. That's the concept of the encrypted wallet here. We'll go back to our little image, our little diagram. Whoops, that's the wrong one. Go back to our little diagram here, and we can see that this is working as intended. This will happen every time. Right now it's in a test state. I haven't implemented into the transactions yet, but it's an isolated function that could easily be added to the transaction. To recap what's going on here just one more time, encrypted wallet exists on your machine. When you want to transact or something, it's decrypted. Actions occur on the blockchain and then encrypted back to the encrypted wallet object. And that is stored on your machine. There will be a wallet manager application that will access this information, and the keys for this encrypted wallet object will be stored on the wallet application at a local level. So the only way somebody could get your information out of your wallet other than you would be they would have to go through this whole process of hacking the wallet, figuring out the encryption standard, all this stuff. It's just not going to happen. It's a good way to keep the information safe. So that's the encryption standard for this Thetis blockchain and the wallet application that will occur. Next, we'll talk about this other concept which also uses encryption, and this is the concept of the Encrypted Blockchain Asset token standard. So, first part's the same thing. Encrypted wallet object exists on your computer, passes an encrypted object to the Thetis blockchain where it's decrypted, and things can occur here. That's the same in both examples here. But what the EBA token standard is, the Encrypted Blockchain Asset token standard, is essentially it's a natural evolution of the NFT token standard. So we'll take a brief look here, a little explanation of what an NFT is. You have your blockchain. You have an NFT token, non-fungible token, that communicates with the blockchain. And it's basically a smart contract that says, hey, this person, the token owner, owns this asset, and it's pointing at something. And what that asset is, currently in today's meta, let's say, it's usually just a picture file. Or it can be any other kind of file. But for this example, we're just using images. So like a Bored Ape or something like that, or some other collection, CryptoPunks, all that stuff. It's just an image out there floating in a hyperlink on the internet, and the NFT just points to it and says, hey, this guy that has this, the owner of this token on the blockchain, he owns this asset. But the problem is, this asset is available for anybody to get. Sure, I have a receipt here, a ledger that says I own this asset, but anybody can access that asset. Anybody can manipulate it and can then go and download it and do whatever to this asset. Just because you own it doesn't mean that you actually control it. And that's what the EBA, Encrypted Blockchain Asset idea, is designed to actually combat. It's designed to reinvent that whole concept. So we'll take a look here at how this actually works. The encrypted wallet object, it does its encryption, decryption thing here with the blockchain, one of these. It passes up an encrypted object that gets decrypted on the blockchain, and then there's still an NFT token. There's still a contract here that says, hey, this person owns this asset, but this asset is also encrypted with a symmetric key, an AES symmetric key. The only person that can access this asset is the person that has that key, which is then put into the wallet. It's encrypted again and then put into the wallet. So all this stuff along the way, it's all being encrypted. And there's no way for anybody to mess with this information whatsoever unless you are the token holder. And that will be again done at a local level inside of the wallet manager application. So let's take a look at an example of this in action. So we'll say encrypt image. And name the file that you want to encrypt. So here we have the Thetis picture. This picture was generated with AI, and then I added my little logo here for Thetis. That this is what I'm working on, the blockchain's name, and I made the logo and I put it on here. This was a really cool image that AI generated for Thetis, the goddess of water, sitting in front of a lake, and the sun out in the distance. It's just I think it's very beautiful, and it was well done. This is my test image here that we're going to be encrypting. So imagine this was your thing you wanted to make into an EBA, into an encrypted blockchain asset. So we'll just say here, test, enter the wallet address of the asset on the blockchain. So here we're going to go, and we're going to take this same one here. And as you can see here, test is now, you can't mess with it at all. It's already encrypted. That other one was the file before it was updated. So it's encrypted already, but I do got to put my wallet address in here to finish the transaction. So it encrypts it. After it has been encrypted, it then does a blockchain action here where it says, oh, this is the creator, the EBA creator, and it signs it with the previous and current hash and the name of the creator. So now there's an associated event on the blockchain that says this guy now owns this encrypted asset. I come back here and I look at the test. It's still encrypted. I can't open it. I can't mess with it in any way, shape, or form. It has been encrypted. And so in a real world situation, a couple use cases for that might be, the one that I was thinking of that would be a good example would be you're an art gallery, but a digital art gallery. And these digital artists out there, they want to show their work off at your art gallery that has screens and everything like that. And to make sure that nobody can access those files and get access to the originals unless you're showing them at your gallery, you can actually encrypt them. And then the art gallery owner would be the owner of the token. And so every time he goes out there to put them on display, he just decrypts them and puts them on display, and then at the end of the day he encrypts them again, and he can show them as much as he wants. And then if somebody purchases one from the art gallery, let's say, then it would just transfer the token over, and then that person is the only person that can look at the image file. This also has other applications. One other application I was thinking of is notarization of documents. So imagine you're like a government agency or something like that needs, you need to have security when you're transferring a document between two agencies or two divisions of the government, or some other big corporation that needs this security protocol to make sure that nobody can access the data from one place to the other. So what you could do then is you could do the same thing. You could encrypt it, say on the blockchain, hey, this division owns it, encrypt the image, and then pass it along, and then the other person passes the token, they get the key, they unlock it on the other side. If anybody intercepts that while in transit, there's no way for them to decrypt the image, or the document in this case. So that would be another example. There's plenty of examples for why this would be relevant. It's really relevant for securing information. It has relevance in protecting digital rights and management at a more anonymous level, more not necessarily anonymous, but more distinct, let's say, more isolated from, let's say, DRM, where it's at a system or an operating system level. And this is more just abstracted away from that, so that you can do it outside of a DRM system or something like that, and buy and sell assets that have been encrypted and nobody can get access to it. So unlike the NFT, where anybody can access it, anybody can copy it, anybody can paste it, even though it says I own it, there could be millions of copies on the internet. In this case, only one person can actually access the encrypted file. So we'll come back here. I'm just going to stop it and go back again because a lot happened, so we don't have to scroll through. And we'll say decrypt the image. We're still at a breakpoint here. And we'll just say test. Decrypted successfully, and this hasn't been signed to the blockchain yet, but eventually this will also sign to it. There'll be a creation event, transfer events, and then encryption and decryption events. Everything will be signed to the blockchain so that you can tell who has opened it, who has closed it, everything like that. Currently, only the creation event is actually being signed to the blockchain, and we can say C to look at that. And so these are all this is the event here. I did a couple more tests, right? These are all different tests trying to create the wallet. And so this will actually be, this blockchain actually will also be encrypted in transit. So everything that's happening here, this will all be scrambled before you pass it on the node network. So yeah, everything's working as intended. We can go back here just to make sure and see that Thetis is now openable again. I can look at Thetis again. You can open it, interact with it, everything's all good there. So the encryption standard is working there. The EBA, in proof of concept of the EBA token standard, is working. So we'll come over to my little thing here. Last thing I want to talk about before I go for today. So this is my little rubric here. Again, poorly drawn, but it's just me thinking out how to do things. Phase 1 is complete right now, which was just to do the localized wallet encryption and encrypted blockchain assets. All of this stuff here was phase 1 before I can move on to actually making a Thetis PTP node network and a wallet manager application. So I'm starting this now. In the next few days, I will be starting actually making a wallet manager application in .NET MAUI, and then the Thetis PTP node network to communicate between wallet applications. This is starting up now. So that's starting. And then the long-term plan here is to have buying ETS tokens from a PayPal holdings account, because the way it works is that there's actually a holdings account that holds the amount of money that you put in the USD. This is the ETS token. You put USD in, and then when you sell off it, if you want to sell some tokens, it sells it back to USD directly inside of the wallet application from the holdings account that everybody's putting money into, and then just goes to external accounts, or you can, however that's going to work, it'll either put it into other people's PayPal accounts or send it to bank accounts, whatever it is. But you can buy and sell inside of the wallet itself is the idea, and that there will always be USD available for people to trade. And then there's also the OAuth authentication layer, which is going to facilitate all of this occurring. There will be OAuth authentication that will protect this with a layer of security. So not only is it all encrypted, sorry, got something in my throat. Not only is this all encrypted, there's also an OAuth authentication layer that protects it with identity. So the idea here is that this is a miningless blockchain. There's no mining occurring. There's no gas fees, nothing like that. I'm not paying miners. I'm not doing everything. Everything is self-mined. Each block is mined when the transaction occurs. That transaction only occurs between two nodes on the network, and it is decrypted. Things happen, re-encrypted, and for that to occur, there's an OAuth authentication layer that says, hey, this person is this person and this person. It will authenticate both people and say these people want to make a transaction. So this is the proof of trust concept that I'm working on here. That's way different than proof of stake or proof of work, because the reason why I'm doing that, there's lots of reasons, but one reason is that it's quicker, it's faster, it'll be cheaper to maintain the network that way. It's way less energy expensive, so there's less energy being involved here. So it's environmentally friendly, we could say, as compared to running mining centers for other blockchains like Bitcoin or Ethereum. So there's plenty of reasons why. Also, this is a good idea here for buying and selling tokens without needing to go through different liquidity providers or through central exchanges, because the wallet manager application itself will essentially be the central exchange for ETS tokens. All right, that's it for today. Just wanted to talk about the encryption standard and EBA tokens, and moving on to the next phase of the blockchain and what we're going to do there.